Hello everyone, welcome back. So ReactJS is introducing two new features, mostly view transitions activity. So let's go through this blog post which they have just published. In React Lab post, we write about projects in active research and development. In this post, we are sharing two new experimental features that are ready to try today and updates on other areas we are working on now. So today we are excited to release documentation for two new experimental features that are ready for testing: view transitions and activity. We are also sharing updates on new features currently in development: React performance tracks, compiler IDE extensions, automatic effect dependencies, fragment refs, concurrent stores. New experimental features: view transitions and activities are now ready for testing in React experimental. These features have been tested in production and are stable, but the final API may still change as we incorporate feedback. You can try them by upgrading React packages to the most recent experimental version. Read on to learn how to use these features in your app or to check the newly published docs. View transition, a component that lets you activate an animation for a transition. Add transition type, a function that allows you to specify the cause of a transition. Activity, a component that lets you hide and show part of the UI. View transition, React view transition are a new experimental features that makes it easier to add animation to UI transitions in your app. Under the hood, this animation uses the new Start View Transition API available in most modern browsers. To opt into animating an element, wrap it in the new View Transition component. This new component lets you declaratively define what to animate. When an animation is activated, you can define when to animate by using one of these triggers for a view transition. By default, this animation use the default CSS animations for view transition applied. Typically a smooth crossfade. You can use view transition pseudo selectors to define how the animation runs. For example, you can use star to change the default animation for all transitions. When the DOM updates due to an animation trigger like start and transition, use default value or a suspense fallback. Switching to content, React will use declarative heuristics to automatically determine which view transition components to activate for the animation. The browser will then run the animation that's defined in the CSS. If you are familiar with the browser's view transition API and want to know how React supported, check out how the view transition work in the docs. In this post, let's take a look at few examples of how to use view transition. We'll start with this app which doesn't animate any of the following interaction. Click a video to view the details. Click back to go back to the feed. Type in the list to filter the videos. Okay. Then view transition do not replace CSS and JS driven animation. View transition are meant to be used for UI transitions such as navigation, expanding, opening, or reordering. They are not meant to replace all the animations in your app. In our example app above, notice that there are already animations when you click the like button and in the suspense fallback glimmer. These are good use cases for CSS animation because they are animating a specific element. Animating navigation, our app includes a suspense enabled router with page transition already marked as transition, which means navigations are performed with start transition. Start transition is a view transition trigger, so we can add view transition to animate between pages. When the URL changes, the view transition and new route are rendered. Since the view transition was updated inside of start transition, the view transition is activated for an animation. By default, view transition includes the browser default crossfade animation. Adding this to our example, we now have a crossfade whenever we navigate between pages. Since our router already updates the route using start transition, this one line change to add view transition activates with the default crossfade animation. If you're curious how this works, see the docs for how does view transition works. Opting out of view transition animation. In this example, we are wrapping the root of the app in view transition for simplicity, but this means all transition in the app will be animated, which can lead to unexpected animations. To fix, we are wrapping route children with none, so each page can control its own animation. In practice, navigation should be done via the enter exit props or by using transition types. Customizing animation. By default, view transition includes the default crossfade from the browser. To customize animation, you can provide props to the view transition component to specify which animations to use based on how the view transition activates. For example, we can slow down the default crossfade animation and define slow fade in CSS using view transition classes. Now the crossfade is slower. See styling view transition for a full guide on styling view transition. Shared element transition: when two pages include the same element, often you want to animate it from one page to the next. To do this, you can add a unique name to the view transition. So view transition name. Okay, now the video thumbnail animates between the two pages. By default, React automatically generates a unique name for each element activated for a transition. See how does view transition work. When React sees a transition where a view transition with a name is removed and a new transition with the same name is added, it will activate a shared element transition. For more info, see the docs for animating a shared element. Animating based on cause: sometimes you may want elements to animate differently based on how it was triggered. For this use case, we have added a new API called add transition type to specify the cause of a transition. So here I have one function, and here I just call start transition, add transition type. Okay, with transition type you can provide custom animations via props to view transition. Let's add a shared element transition to the header for 6 videos and back. Here we pass a share prop to define how to animate based on the animation type. When the shared transition activates from nav forward, the view transition class slide forward is applied. When it's from nav back, the slide back animation is activated. Let's define this animations in CSS. Now we can animate the header along with the thumbnail based on navigation type. Animating suspense boundaries: suspense will also activate view transition. To animate the fallback to content, we can wrap suspense with view transition. By adding this, the fallback will crossfade into the content. Click a video and see the video info animate in. We can also provide custom animation using an exit on the fallback and enter on the content. Here's how we will define slide down and slide up with CSS. Now the suspense content replaces the fallback with a sliding animation. Animating list: you can also use view transition to animate list of items as they reorder, like in searchable list of items. To activate the view transition, we can use default values. Now the items animate as you type in the search bar. Final result: by adding a few view transition components and a few lines of CSS, we were able to add all the animation above into the final result. We are excited about view transition and think they will level up the apps you are able to build. They are ready to start trying today in the experimental channel of React releases. Let's remove the slow fade and take a look at the final result. So here you can see this is the final result. If you are curious to know more about how they work, check out the docs, and for more background on how we build view transition, you will have to see all this PR. Next is activity. In past updates, we shared that we are researching an API to allow components to be visually hidden and deprioritized, preserving UI state with reduced performance cost relative to unmounting or hiding with CSS. We are now ready to share the API and how it works, so you can start testing it in experimental React version. Activity is a new component to hide and show parts of the UI. When an activity is visible, it's rendered as normal. When an activity is hidden, it is unmounted but will save its state and continue to render at a lower priority than anything visible on screen. You can use activity to save state for parts of the UI the user isn't using, or pre-render parts that a user is likely to use next. Let's look at some example improving the view transition examples above. Effects don't mount when an activity is hidden. When an activity is hidden, effects are unmounted. Conceptually, the component is unmounted, but React saves the state for later. In practice, this works as expected. If you have followed the "you might not need an effect" guide to eagerly find problematic effects, we recommend adding strict mode, which will eagerly perform activity unmounts and mounts to catch any unexpected side effects. Refactoring state with activity: when a user navigates away from a page, it's common to stop rendering the old page. However, this means if the user goes back to the old page, all of the previous state is lost. For example, if the home page has an input field, when the user leaves the page, the input is unmounted and all of the text that has been typed is lost. activity allows you to keep the state around as the user changes page, so that when they come back they can resume where they left off. This is done by wrapping part of the tree in activity and toggling the mode. With this change we can improve on our view transition example above. Before, when you searched for a video, selected one and returned, your search filter was lost. With activity, your search filter is restored and you can pick up where you left off. Try searching for a video, selecting it and clicking back. Pre-rendering with activity. Sometimes you want to prepare the next part of a UI a user is likely to use ahead of time, so it's ready by the time they are ready to use it. This is especially useful if the next route needs to suspend on data it needs to render, because you can help ensure the data is already fetched before the user navigates. For example, our app currently needs to suspend to load the data for each video. When you select one, we can improve this by rendering all of the pages inside a hidden activity until the user navigates. With this update, if the content on the next page has time to pre-render, it will animate in without the suspense fallback. Click a video and notice that the video title and description on the detail page render immediately without a fallback. Server-side rendering with activity. When using activity on a page that uses server-side rendering, there are additional optimization. If part of the page is rendered with mode equal to hidden, then it will not be included in the SSR response. Instead, React will schedule a client render for the content inside activity while rest of the page hydrates, prioritizing the visible content on screen. For parts of UI rendered with mode equal to visible, React will deprioritize hydration of content within activity, similar to how suspense content is hydrated at lower priority. If the user interacts with the page, we will prioritize hydration within the boundary if needed. There are advanced use cases, but they show the additional benefits considered with activity. Future modes for activity. In future, we may add more modes to activity. For example, a common use case is rendering a model where the previous inactive page is visible behind the active model view. The hidden mode does not work for this use case because it's not visible and not included in SSR. Instead, we are considering a new mode that would keep the content visible and included in SSR, but keep it unmounted and deprioritize updates. This mode may also need to pause DOM updates, since it can be distracting to see background content updating while a model is open. Another mode we are considering for activity is the ability to automatically destroy state for hidden activities if there is too much memory being used. Since the component is already unmounted, it may be preferable to destroy state for the least recently used hidden parts of the app rather than consume too many resources. These are areas we are still exploring and will share more as we make progress. For more information on what activity includes today, check out the docs. Features in development. We are also developing features to help common problems below. As we iterate on possible solution, you may see some potential APIs we are testing being shared based on the PRs we are landing. Please keep in mind that as we try different ideas, we often change or remove different solutions after trying them out. When the solutions we are working on are shared too early, it can create churn and confusion in the community. To balance being transparent and limiting confusion, we are sharing the problems we are currently developing solutions for without sharing a particular solution we have in mind. As these features progress, we announce them on the blog with docs included so you can try them out. React performance tracks. We are working on a new set of custom tracks to performance profilers using browser APIs that allows adding custom tracks to provide more information about the performance of your React app. This feature is still in progress, so we are not ready to publish docs to fully release it as an experimental feature yet. You can get a sneak preview when using an experimental version of React, which will automatically add the performance tracks to profiles. There are few known issues we plan to address, such as performance and the scheduler track not always connecting work across suspended trees, so it's not quite ready to try. We are also still collecting feedback from early adopters to improve the design and usability of the tracks. Once we solve those issues, we'll publish experimental docs and share that it's ready to try. Automatic effect dependency. When we released hooks, we had three motivations: sharing code between components. Hooks replaced patterns like render props and higher order component to allow you to reuse stateful logic without changing your component hierarchy. Things in terms of function, not lifecycle. Hooks lets you split one component into smaller function based on what pieces are related, such as setting up a subscription for fetching data rather than forcing a split based on lifecycle methods. Support ahead of time compilation. Hooks were designed to support ahead of time compilation with less pitfalls, causing unintentional de-optimizations caused by lifecycle methods and limitation of classes. Since their release, hooks have been successful at sharing code between components. Hooks are the new favored way to share logic between components, and there are less use cases for render props and higher order component. Hooks has also been successful at supporting features like fast refresh that were not possible with class components. Effects can be hard. Unfortunately, some hooks are still hard to think in terms of function instead of lifecycle. Effects specifically are still hard to understand and are the most common pain point we hear from developers. Last year we spent a significant amount of time researching how effects were used and how those use cases could be simplified and easier to understand. We found that often the confusion is from using an effect when you don't need to. The "you might not need an effect" guide covers many cases for when effects are not the right solution. However, even when an effect is the right fit for a problem, effects can still be harder to understand than class component lifecycle. We believe one of the reasons for confusion is that developers to think of effects from the component's perspective like a lifecycle instead of the effects point of view. What the effect does, let's look at an example from the docs. Many users would read this code as on mount connect to the ROM ID. When ROM ID changes, disconnect to the old ROM and recreate the connection. However, this is the thinking from the component's lifecycle perspective, which means you will need to think of every component lifecycle state to write the effect correctly. This can be difficult, so it's understandable that effects seem harder than class lifecycles when using the component perspective. Effect without dependency. Instead, it's better to think from the effects perspective. The effect doesn't know about the component lifecycle. It only describes how to start synchronization and how to stop it. When user thinks of effects in this way, their effects tend to be easier to write and more resilient to being started and stopped as many times as is needed. We spend more time researching why effects are thought of from the component's perspective, and we think one of the reason is the dependency array. Since you have to write it, it's right there and in your face, reminding you of what you are reacting and to, and baiting you in the mental model of do this when this value changes. When we released React hooks, we knew we could make them easier to use with ahead of time compilation. With the React compiler, you are now able to avoid writing use callback and use memo yourself in most cases. For effects, the compiler can insert the dependencies for you. With this code, the React compiler can infer dependencies for you and insert them automatically, so you don't need to see or write them. With features like IDE extension and use effect event, we can provide a code lens to show you what the compiler inserted for times you need to debug or to optimize by removing a dependency. This helps reinforce the correct mental model for writing effects, which can run at any time to synchronize your component or hook state with something else. Our hope is that automatically inserting dependencies is not easier to write, but it also makes them easier to understand by forcing you to think in terms of what the effect does and not in components lifecycle. Compiler IDE extension. Earlier this week, we shared the React compiler release candidates, and we are working towards shipping the first similar stable version of the compiler in the coming month. We have also begun exploring ways to use React compiler to provide information that can improve understanding and debugging your code. One idea we started exploring is a new experimental LSP based React IDE extension powered by React compiler, similar to the extension used in Laurentan's React Conf talk. Our idea is that we can use the compiler's static analysis to provide more information, suggestion, and optimization opportunities directly in your IDE. For example, we can provide diagnostics for code breaking the rules of React, hovers to show if components and hooks were optimized by the compiler, or a code lens to see automatically inserted effect dependency. The IDE extension is still an early exploration, but we'll share our progress in future updates. Fragment refs. Many DOM APIs like those for event management, positioning, and focus are difficult to compose when writing with React. This often leads developer to reach for effects managing multiple refs by using APIs like find DOM node. removed in React 19. We are exploring adding refs to fragments that would point to a group of DOM elements rather than just a single element. Our hope is that this will simplify managing multiple children and makes it easier to write composable React code when calling DOM APIs. Fragment refs are still being researched. We'll share more when we are closer to having the final API finished. Gesture animation, we are also researching ways to enhance view transition to support gesture animation such as swiping to open menu or scroll through a photo carousel. Gesture present new challenges for a few reasons. Gestures are continuous. As you swipe, the animation is tied to your finger placement time rather than triggering and running to completion. Gestures don't complete when you release your finger. Gesture animation can run to completion or revert to their original state, like when you partially open a menu, depending on how far you go. Gestures invert old and new. When you are animating, you want the page you are animating from to stay alive and interactive. This inverts the browser's view transition model, where the old state is a snapshot and the new state is the live DOM. We believe we have found an approach that works well and may introduce a new API for triggering gesture transition. For now, we are focused on shipping view transition and will revisit gestures afterward. Concurrent stores, when we released React 18 with concurrent rendering, we also released use sync external store. So external store libraries that did not use React state or context could support concurrent rendering by forcing a synchronous render when the store is updated. Using use sync external store comes at a cost though, since it forces a bailout from the concurrent features like transition and forces existing content to show suspense fallbacks. Now that React 19 has shipped, we are revisiting this problem space to create a primitive to fully support concurrent external stores with the use API. Our goal is to allow external state to be read during a render without tearing and to work seamlessly with all of the concurrent feature React offers. This research is still early. We'll share more and what the new API will look like when we are further along. So yeah, that's it. Thank you for watching. Bye.